features of sine and cosine functions from their equations. Today we're going to talk about key features of sine and cosine functions. The four features that we're going to worry about, or the ones that we're going to work on finding, are the amplitude, the period, the phase shift, and the vertical shift. All right. So the amplitude, the easiest way to think of it is kind of the height above what I like to refer to as the midline. All right, so normally the midline for sine and cosine is the x-axis. So my amplitude is how high above the x-axis or how far below the x-axis that my graph goes. All right, if the midline has been shifted, then it is how high above the midline, how low above the midline. It's also, if I count from the highest peak of my graph to the lowest peak, it's half of that. So if the top of the graph is at 4 and the bottom of the graph is at -4, that's an 8-unit swing, and so my amplitude would be 8 divided by 2. All right, but we'll get to that. All right, period is, the easiest way to think about it is just how long it takes to repeat. All right, so as you'll see in a minute, sine and cosine are graphs that basically do the same thing over and over again. So they go from negative infinity to positive infinity and just do the same thing over and over again because it's part of a circle. You can go around a circle, an infinite number of times. So that means my graph of sine and cosine is also infinite as well. The period is just how long it takes before it repeats itself. Phase shift is just a fancy name for my horizontal shift. Now, the phase shift and horizontal shift are basically the same thing. Phase shift is usually based on a measurement. So like if it's radians, the phase shift might be pi radians. If it's degrees, it might be 60 degrees. All right, but the phase shift is, when we look at the pictures of sine and cosine in just a second, my sine and cosine graphs always start on the y-axis at a specific spot. All right, if that spot is not on the y-axis, there has to be some sort of phase shift. Okay, and we'll look at that when I show you the picture in just a minute. Vertical shift is just that, it's a vertical shift. And it's usually relative to that midline. So if the midline, so if I go from the highest peak to the lowest peak and find the middle of that and it's no longer the x-axis, there has been some vertical shift. And we'll see more of that when we're finding the key features from graphs. So here's some pretty crappy drawings of sine and cosine functions, but this is just the general idea so I can kind of show you how it works. So notice that my sine function starts on the y-axis at 0. All right, so it starts here and goes up. All right, if your sine function doesn't start at 0, 0 and then go up as it goes to the right, there has been a phase shift or a vertical shift, or both. All right, so when I look at this, so if my x-axis is my midline, so the distance from this x-axis to the peak, that's the amplitude. Okay, so how high above the midline, how far below. All right, my period, I can go from peak to peak, or I can go from where it starts to where it finishes. So like it starts here, it gets there, and now my graph is about to do the same. So each one of these represents a full rotation of the circle or a full period of my graph. All right, in this case, there is no phase shift or vertical shift. So if my midline is x, if I took this whole graph and shifted the whole thing up, my midline would raise, and that would give me a vertical shift. If my starting point is no longer at 0, 0, let's say it's starting here, then I'd have a phase shift. All right, cosine starts at the peak and goes down. So if my cosine starts anywhere other than this peak and then goes down to the right, there has been a phase shift. All right. Now, the amplitude is still the same. It still goes from the midline to my highest point. So that's my amplitude. And then my period goes, in this case, from peak to peak is the easy way to think about this one. You can also calculate your period for sine going from peak to peak, because that would still be how long it takes before it repeats itself. These are my two equations for sine and cosine functions. Notice that they're basically the exact same thing. All right, the only thing different is the word that's written right here, sine versus cosine. A's in the same place, B's in the same place, C's in the same place, D's in the same place, and they all mean the same thing. Okay, so let's look at how this gives me my information. So for instance, letter A is my amplitude. Okay, my period is based on B, but it's not B by itself. Okay, so to find my period, I have to take a full rotation. Okay, so if the sine cosine is in degrees, I would use 360. If it's in radians, I'd use 2 pi. So it's either going to be 2 pi divided by the absolute value of B, or it's going to be 360 divided by the absolute value of B. That's how I find my period. All right, so here's B. Now, the question is, do I use 2 pi or 360, which it's easy if you have a C. If you don't have a C, then it's kind of tough to tell, but it would give you the same graph. Now, if you have a C and C's in radians or degrees, then you automatically know whether it's in radians or degrees. If you have a picture of the graph and the X units are in radians or degrees, that tells you whether it's in radians or degrees. Okay? Now, my phase shift notice it says my phase shift equals C. This says minus C, X minus C. So that means when I go from minus C to C to find phase shift, which I left a T off, find phase shift, we have to make sure that when I write it down, I change the sign. So if this said X minus 5, see, the phase shift would be 5. Like it wouldn't be minus 5. All right. And the vertical shift is just D. Okay, so amplitude and D are the letters that are there. Period is one full rotation of a circle divided by the absolute value of whatever B is, and then my phase shift is the opposite sign of what C is in the actual problem. Now, one thing I want to point out before I really dive into finding these features is a lot of times the parentheses in the problem will look like this, where it says 4x minus 8 pi. So right now you're thinking C is 8 pi, but it's not really. All right, so when I wrote out my equation, the parentheses should look like this, or at least this is the easiest way to find B and C to write my feature. So when I look at this, notice this is B parentheses X minus C, and this does not look like that, okay? But it's pretty quick and easy. This is what I'm looking at as B. So I just divide both of these by 4, or in this case, I factor out whatever number's in front of that X. So when I factor that out, that gives me 4 parentheses X minus 2 pi. And now this does look like B parentheses X minus C. Okay, so when we're looking for key features from an equation, we have to make sure that we factor out B first to find A, B, C, and D. When I write the equation from a graph, I'm going to write it like this first, and then I'm going to need to distribute to get back to this part. Okay, and we'll deal more with that tomorrow. All right, look at my first example. It's by far the easiest one. So this is sine, so that means I know that I'm looking at y equals A times the sine of B times X minus C plus D. So let's identify what is not there. Okay, do I have plus or minus anything for the X? No. Do I have plus or minus anything outside of the parentheses? No. So that means automatically I know that there is no phase or vertical shift. Okay, there is no phase or vertical shift. All right, so now we're looking at A and B. Notice this is A times sine, B times X. If nothing's written there, then there is really a 1. So if this is blank, this is saying 1 times the sine of 1 times x. So in this case, A equals 1, B equals 1. So my amplitude is 1 because amplitude is A, but my period is 2 pi over 1 or 360 over 1, depending on whether it's in radians or degrees. So in other words, my period is just 2 pi or 360 degrees. All right, so make sure you pay attention to whether or not something is missing. All right, A and B are both multiplied to something. So if they're not written there, they're a 1. But C and D are added or subtracted. So if they're not written, it's a 0. Looking at my next example, it's a cosine. So that means in order to find my key features, I want to make sure it looks like this. Y equals A times the cosine of B parentheses X minus C, close parentheses, plus D. All right, so when I look at this, notice that this right here does not look like B parentheses X minus C. So this is where I was talking about. To write it like this, I would factor out 2. So I'd factor out 2, or I divide both of these by 2, and B would be 2. So when I rewrite it in this manner, it would still be Y equals the cosine of 2 parentheses X plus pi over 2. Now, this looks like the way we want to write it, so I can write down my features. So let's look and see what's missing. I don't have an A, so that means my amplitude is a 1, because if nothing's written there, it is an amplitude. All right, now I need to find my period. All right, period is 1 full rotation of the circle divided by whatever B is. Now, since this says pi over 2, that means I am in radians. So that means I would do 2 pi divided by 2, absolute value of 2, because B is 2. So that means my period in this case is pi. All right. Now, I don't have a D, so there's no vertical shift, but I do have a C. So my phase shift is my C value. So if this is pi over 2 and it's positive, my phase shift is C, but I have to change the sign. So my phase shift will be negative pi over 2, and then there is no vertical shift. All right, don't forget the original form is X minus C. So if this says X plus C, then I have to change it to negative from actual phase shift. All right, I'm gonna take a look at this one. Notice once again, there's gonna be a phase shift and vertical shift. It is in radians, so I need to make sure that I do the whole thing in radians. All right, so I know that I want it to look like Y equals A times the sine of B parentheses X minus C plus D. So I have to fix this parentheses to make it look like that to make my life easier. So I factor out a 6. All right, so that gives me Y equals 1/4. Please notice that I'm always factoring out whatever number's in front of the X every time. All right, so I get 1/4 sine of B is 6 parentheses X plus 2 pi over 3 plus 5. So amplitude finds my period, phase shift, vertical shift. So amplitude is 1/4. My period is, so this is in radians, so my period should be in radians. So it is 2 pi divided by 6, which is pi over 3. My phase shift is 2 pi over 3, and since it's positive there, it needs to be negative 2 pi over 3. And then my vertical shift is positive 5. So I have an amplitude of 1/4, so that means my graph has actually gotten smaller. A period of pi over 3, a phase shift of 2 pi over 3, and a vertical shift of 5 units. All right, for these last two, I'm gonna go a little bit quicker and just go ahead and set it up. So I need to rewrite this, factor out of 4, factor out of 4. I get Y equals 2 cosine of 4x, 4 parentheses X minus pi over 4 plus 1. So that means my amplitude is 2. My period, this is also in radians, so it is 2 pi over 4, which gives me pi over 2. I have a phase shift of positive pi over 4, and I have a vertical shift of 1. A, B, C, D. And the last one, notice that the last one is in degrees instead of radians. So once again, I need to factor out a 1/2. So when I factor out a 1/2 here, that will give me x minus, and when I divide 180 by 1/2, that makes it 360. And that's a 3 up there. So I end up with y equals 1/2 cosine of 1/2 parentheses x minus 360 plus 3. So that means my amplitude is 1/2. My period, please take note that this one is in degrees. So this would be 360 degrees divided by 1/2, which is essentially multiplying by 2. So that's 720 degrees. I have a phase shift of positive 360 degrees because I have to change the sign, and a vertical shift of 3.